stopped the video in the last one because this is kind of a little bit difficult to explain. It's like the Caesar cipher, if you remember what I did where we were shifting the alphabet along one. It's very, very similar, but not exact. So what I'm talking about here is we started off with this one, with the odd of B gave me 98. So if I type here, odd B, I know that that value is 98. And if I exclusively OR that with 1, that will give me a number. So it's taking all the bit patterns for B and exclusively ORing them. So I can't remember what the bit pattern for B is. But as you can see, when I pressed enter, we've got 99, which is the value for C. I'll explain exclusive OR shortly. But what I want to point out is I can do the reverse operation of this. So if I do the character of 99, whoops, and exclusively OR that with 1. So I'm taking 99, exclusively ORing it with 1, and when I press enter, it should give me the character B back. So I started off with B, exclusively ORed that. That gave me C, because char 99 is C. Then I did the same thing, char 99, exclusively ORed that with the same value, the same key, and it gave me back my original value. And I can do that all the time. So it looks like it's just moved it on one character, but it hasn't. It's not a straightforward Caesar cipher. So let's take a look at that. So let me exclusively OR it with a bigger value. So I've got a different key. So let me take the odd of B, which you know should be 98. Exclusively OR that with, this time, 2, the key of 2. And that gives me 96. So it's, when I did it this way round, it gave me the value C, which was add 1. This time it seems to have taken 2 away. But I can restore what I had by doing char 96, exclusively ORing it with 2, and that should give me my B back. So this is a nice way of coding things, because I can use the same key to encode it and decode my message. Now, if you didn't follow that, that is perfectly understandable. It is even hard for me to explain. It might be nice if I might do this, I might produce a list of what happens when we exclusively OR something with 1 or with 2 or with 3 and so on. The difficulty is when we are doing A. So let's take a look at order of A, and we should know that should give us 97. But if I exclusively OR 97 with 1, so if I do what is the character, if I have 97 and exclusively OR that with 1, I don't end up in the alphabet, I end up outside of the alphabet with something called the backtick. And it would be the same if I did it with 2, 97, exclusively OR that with 2. You might think I might end up outside the alphabet, but actually I end up inside the alphabet and 2 characters along. And we can see if we do char 97 and do it with 3, So we're exclusively ORing it with 3. A with 3, we get the value B. So what is actually happening is it's alternating forward and backwards, forwards, backwards, forwards, backwards when we're using these. So again, if I did char 97, which is the value for A, and exclusively ORed it with 4, I'm going to end up outside of the alphabet before. Oh no, I'm not. I'm going to end up on E. So even for me, it's difficult to guarantee where we're going to end up. What we do have is we have some coding, some way of encoding our work and decoding it. And you're going to have to trust me that this works. So we'll start taking a look at that by building our decode function in the next video.